In Java, a constructor is a special type of method that is automatically called when an instance or object of a class is created. We'll look at constructors in this video. They are used to initialize the state of an object, which includes setting initial values of instance variables and performing any other setup tasks necessary for the object to function correctly. This is an example of a constructor for the circle class. There's a few things to note. The name of the constructor is the name of the class. Or we can say the constructors have the same name as the class in which they're defined. They look very similar to a method, except constructors don't have a return type. There's parameters list. Sometimes you can have multiple parameters defined, or you can have just one in this case. Otherwise, everything looks like a method. You also have the constructor scope encapsulated within a pair of curly braces. Let's look at more of this. You will notice that sometimes a constructor has no parameters at all. They're what we call no arc constructor. The default constructor is part of a no arc constructor. Sometimes you could have a default constructor, but you have your own custom user-defined logic in the constructor scope. Then that would not be a default constructor. We already talked about constructors having the same name as the class itself. Constructors do not have a return type, not even a void. Constructors are invoked using the new operator when an object is created. This is very important. This new operator allocates space. When an object is created, it could end up in the stack memory space, or it could end up in the heap memory space. This new operator is actually for heap memory management. In contrast, for object created in the stack memory, you don't use the new operator. This is a little more advanced. We talked about this in a later video. Just remember, 1, constructor must have the same name. 2, constructors do not have a return type. And 3, constructors are used to initialize objects. Any properties you wish to have a initial values for, you will put them inside the constructor. Note, when an object is created at construction time, initializing its properties at construction time is the most efficient thing to do, because that one ensures all of the properties and behaviors associated with that class are initialized. So there is no tampering of any of these data in a complex software system. This is the reason why we use constructors, to initialize objects. Let's look at some examples. We see the new operator. This means in a memory cloud like this, a large portion of it is what we call heap memory. This is a dynamically allocated space for anything that were to be instantiated or created using the new operator. This operator sets aside a spot inside your heap memory, ensuring that spot has sufficient memory to hold this entire class name. By the way, this class name is a class, let's say circle. So this entire blue area should be sufficient to store this circle class. There is a memory location specific for this circle class here. Let's say x times FA21. It's a memory address. This new operator simply returns the memory address of this class name object or circle object at runtime back to whoever references it. For example, let's say we construct a circle object. At runtime, this blue area is born containing the circle object. Same thing with this, using a user-defined constructor with a value of 5.0 into it, assuming this is the radius. There could be another blue area here, storing this circle, and this new returns the memory address of this particular spot containing the circle 5.0. The outcome of new circle is object 1, which sits right here. The outcome of the second new circle is object 2, which sits here. They all occupy different memory spaces. But because they're using new, both of these instances, objects 1 and 2, are located in this heap memory. Object and instance in OOP language, they are synonymous. Both refer to something that is concrete at runtime that holds memory space that could be used by any software object. Let's look at default constructors next. Sometimes you may see a class without any constructors. This is because the default constructors is automatically supplied by your compiler. If you don't include this default constructor, you'll still have it at runtime. A default constructor is very easily discerned. It simply carries a name that is exactly the same as your class name with no arc, and there's an empty body. It says this is implicitly defined, which means you don't have to define it really if there's nothing else you wish to add to it. A constructor is the entry point for instantiating your class into an object. This is a very important fact. This is the reason sometimes you don't see any constructors at all in a class definition. One last note, constructors are an essential part of Java classes responsible for initializing objects and setting up their initial state. Understanding how to define and use constructors is fundamental for creating well-designed and functional Java programs. So please take the time to understand constructors, their construct, and their use cases.